Alrighty. We are starting antiderivatives or indefinite integrals. Yeah. So before we can get into that, I got to make sure you know your derivatives. So what I'd like you to do for the do now is just fill in the left side of the table. Tell me the derivatives of those functions. Got it? All right. Time to pause. All right, guys. What is the derivative? Now, k is always a constant. That's one of the letters that we've used for constants. So what's the derivative of a constant? Nice. What's the derivative of x to the n? N times x in minus. All right. What's the derivative of a constant times x, like 3x or 4x? What's the derivative of kx? Okay. What's the derivative of sine x? Derivative of tan x? Tan squared x. The derivative of secant x? Good. Secant x. And x. What about the derivative of e to the x? The derivative of ln of x? Okay, guys. We're good at this. And one more. The derivative of a, let's make it plus or minus because it wouldn't matter. Of f of x plus or minus g of x. F prime of x plus or minus g prime of x. In other words, you're allowed to take the derivative of each term separately. Good thing. All right. Well, we've learned how to find derivatives, and that's basically going in one direction. Today we're going to talk about antiderivatives. We're going to go in the opposite direction. So let me just show you a little notation you got to get used to. When you want to find the antiderivative, the symbol that we use is an integral sign. It's like a big, it looks like an S. And what you will see the integral sign, some expression, and then a dx at the end. And what you have to think of this as being like bookmarks. And in between there is the derivative of a function. And it's your job to figure out what the function is. So it's like, all right, now here's the derivative. The antiderivative is the function. So I gave you this one. The antiderivative of 2x, the function that has 2x as a derivative, would be x squared, but really x squared plus any constant, right? If it was x squared plus 3, what would the derivative be? If the function was x squared plus 3, what's the 2x? What's the derivative of x squared minus 7? 2x. So we don't want to just say that the antiderivative of 2x is x squared, because really it's x squared plus any old constant. And that constant we call the constant of integration. So, and what is the difference between when you start changing c, you make c 3 or -1 or 4, what does it do to this answer? What's the only difference between the graph of x squared plus 7 and the x squared moves it up or down? So moving a graph up or down is not going to change the slope, the derivative. That's why they all have the same derivative. Some terminology. What you're integrating, the argument is called the integrand. So refer to the integrand. And basically, I kind of jumped ahead here, but you can call this the antiderivative or the indefinite integral. And a lot of times we use the same letter, only we use the capital for the antiderivative. We use the lowercase for the derivative. So if you start out by saying the derivative of a function is lowercase f of x, you multiply each side by dx, we'd have an infinitely small change of y. We'd have what dy equals. To get y, we sum up all the infinitely small changes of y. We integrate to get what y equals. Now, this is just a fancy way of saying that if the derivative of a function is lowercase f, the antiderivative of that function would be uppercase F. We'll use the same letter. And so if you know your differentiation formulas, going backwards is not going to be too much of a problem. So what we're going to do, we're just going to go back to all those differentiation formulas, and we're going to work them backwards, except for 1 and 2 for a minute. I'll show you what I'm talking about here. Remember we said that the derivative of k times x is equal to k? So if that's true, what would the antiderivative of k be? Yeah, if the derivative of kx is k, then the antiderivative of k is kx. But not just kx plus any constant c. We do a plus c every time you find an antiderivative. Now, suppose you put that down and you're not sure. Well, take the derivative of your answer here. What would the derivative of kx plus c be? K. As long as it's the original integrand, you're right. You're integrating with respect to x. It's going to tell you the variable. If I was integrating k with respect to t, if that was a dt, then it would be kt plus c. It's going to let you know, and that has to be there. So remember, you can't integrate without a differential on the end to tell you what the variable is. Okay, we said that the derivative of sine x was equal to cosine x. Well, if that's true, then the antiderivative of cosine of x with respect to x must equal sine x. Let's see. We said that the derivative of tan x equals secant squared x. So what would the antiderivative of secant squared x have to be? Good. So the antiderivative of secant squared x with respect to x equals tan x. Let's see. We said the derivative of secant x equals secant x tan x. I know an integration formula. What's the integration formula I know now? The antiderivative of good must equal good. And some of you might have spied there on Friday, you're going to have a quiz on the integration formulas. We've already got, there's a total, I think, of 18 of them. We're already getting some of them. Just by knowing your differentiation formulas, you work them backwards. It's just these formulas. All right, we said the derivative of e to the x equals e to the x. What's the integration formula that follows then? So the antiderivative, good, equals e to the x plus any constant c. Good. Okay, we said that the derivative of the ln of x equals 1 over x. What integration formula follows? So the antiderivative of 1 over x with respect to x equals the ln of x plus c. It's one little thing I have to add with that one. Do you remember what the graph of the ln of x looks like? Anyone show me what it looks like? That was better. That was good. It's like this, right? What's the domain of the natural log of x, or any log? Yeah. And do you include that 0? No. That's right. You can only take logs of positive values. So with this last formula, we don't want to wind up taking the ln of a negative number or 0. So what we do is well, I guess 0, well, it wouldn't be 0 anyway. We just put the absolute values on there. So you can only take logs of positive values. Okay, we got one more. Well, we got to go up and get the top two. We said the derivative of f of x plus or minus g of x equals f prime of x plus or minus g prime of x. So the antiderivative of right minus g of x. Oh, my plus c. Let's see, that's there. So that's telling us when we go to integrate a sum or a difference, we're allowed to integrate each of them separately. By the way, did I tell you, when you read this, you can say the antiderivative of or the integral of e to the x. Just don't say big S. Big S. I don't want to hear that. No big S's in here, right? The antiderivative of or the integral of, that's just fine. Well, I skipped that first one. We'll get back to that one. We said the derivative of a constant equals 0. So what is the antiderivative of 0 equal? Yeah, and we don't have to say a constant plus any arbitrary constant. We just say equals c. It doesn't matter what k is. Right? If you add an arbitrary constant to it, you're going to get another arbitrary constant. Now this one, we're not going to work it backwards exactly. Because if I work this one backwards, it'd be definitely true that the antiderivative of nx to the n minus 1 with respect to x equals that. It would be so awkward, right? You want to know how to integrate x squared or x cubed. So we're going to come up with our own formula so it's not so awkward. And then we'll go back and fill it in. Now don't say anything out loud yet. I just want you to think. When you want the antiderivative of x, you're trying to figure out what's the function so that when you take its derivative, you just get x. So try to write something down and check. If you take its derivative, you get x. Just trying to come up with the antiderivative of x. What the function would be. Anyone have a guess? What do you think, Ken? 1/2 x squared plus any old constant. All right, let's see if that works. If I take the derivative of this, 2 times 1/2 is 1x to the first plus 0. Yeah, that works. Because you can always check if you got it right. Right? If you take the derivative and you get the original integrand, you're good. You got the right antiderivative. All right, take a second, try to figure out what the antiderivative of x squared is. Figure out the function whose derivative is just x squared. Give them a minute. Well, I know you know how to do it. That's good. Don't worry, you guys, the rest of you are going to get it fast too after you see the pattern. All right, Ryan. Well, sorry. I looked back here and then I went over there. Riley, sorry. Yeah. Does that work, guys? If we take the derivative of this, do we get x squared? Yeah, right? So that's good. Okay. Let's try another one. Let's try the antiderivative of x to the 6th. Technically, I already called on you, so I can't call on you. And I know you know, Jillian. AP Physics kids know this. All right, Gina, what do you think? Would you say again? 1/6 to the 6th? All right, now let's see if that works. If you take the derivative of that, you get x to the 6th. Okay, so let's fix it up a little bit. 1/7 x to the 7th. Now that is the antiderivative, because when you take the derivative of 1/7 x to the 7th plus any constant, you get x to the 6th. So looking for a pattern here. I think you got it, Jamie. Is that a hand raised or no? Should this one? Oh yeah, let me hear this, is because this will be a rule that we're looking for. Perfect. So the antiderivative of x to the n is 1 over n plus 1 times x to the n plus first plus c. And if you don't want to multiply by the reciprocal of n plus 1, you could just write it as x to the n plus 1 over n plus 1. It's the same thing, you know, dividing by the new exponent or multiplying by the reciprocal of the exponent. These are both the same. That's the power rule. See, it's good to know the rule like this because you're going to want to integrate x to a power. And if we just worked that other rule backwards, it wouldn't have been very nice. So let's go fill that in on the do now. That was the only one we didn't fill in. So the antiderivative of x to the n dx, let me fit one of them in. Should I do the one where you're dividing or have the reciprocal out front? Divide, just because I'm short on room. So it would be x to the n plus 1 over n plus 1 plus c. Anytime you want to find the antiderivative of x to an exponent, we add 1 to the exponent and then divide by the new exponent or multiply by the reciprocal of the new exponent. Oh wait, that's what we have to do now. So yeah, let's put that in words. So if you want to integrate x to a power, what do we add to the power? We're going to add 1 to the exponent to the power. And then you have a choice. Some people like to multiply, some people like to divide. So then you're either going to divide by the new power, has to be the new power, or you can multiply by the reciprocal of the new power. Dividing by a number or multiplying by the reciprocal, that's the same thing. What am I doing? I'm missing a syllable. So you're going to divide by the new power. After you add 1 to the exponent, then you're going to divide by that new exponent or multiply by the reciprocal of the new exponent. Got it? Let's do it. Oops, that was our filling stuff. Okay, we're going to apply these rules. We want the antiderivative of 7. So that's, I think, the antiderivative of k with respect to x, right? But now our k is a 7. So what do you think 7 is the derivative of? Or what's the antiderivative of 7? That's that k rule. You can take the antiderivative of k. Oops, 7x plus c. The great thing is I have an eraser. If it's not right, I'll get rid of it. But this one is, because if you take the derivative of 7x plus any constant, you get 7. It works. Anytime you integrate a number, you're just going to get that number times x, or whatever the variable is. All right, number 2. The antiderivative of x to the 5th with respect to x. Manny. 1/6 plus c. Perfect. Now, if you want to write that as x to the 6th over 6, feel free. It's the same thing. Write them both. All right, the next one, the antiderivative of x to the 12th, Jared. Oh, he went the other way. So x to the 13th over 13 plus c, right? If you want to write 1/13 x to the 13th, you can do that too. Question. Now, when you want to integrate a sum or a difference, technically you're supposed to put parentheses around the integrand, so you realize you're integrating, everything in there. But you can integrate term by term. Just watch me. Sometimes I forget to put parentheses around it. It's just a bad habit I've got into. So let's first take the antiderivative of x to the 4th. What's that going to be? 1/5 x to the 5th. All right, and then you get the minus the x squared. So it'll be minus, oh, no, you went the other way. So you can say minus 1/3 x cubed or minus x cubed over 3. Just like this first term could be x to the 5th over 5. Plus c. You just integrate each term separately with addition and subtraction. It's no problem. It's no problem. Yep. Yeah, you just write 1, because if suppose I put in like plus c, that would add up to some other arbitrary constant. Okay, so that's why you don't even bother. All right. Oh, now we got t's. That makes it interesting. Okay, what's the antiderivative of t cubed? Okay. T to the 4th over 4, or 1/4 t to the 4th. Correct. Plus the antiderivative of t. Add 1 to the exponent, Jamie. T squared over 2, so plus t squared over 2, or 1/2 t squared. Ooh, what about the antiderivative of 1 with respect to t? What's 1 going to be the derivative of? Yes, Kim. Just t plus t. And then we need plus c. So we have t to the 4th over 4 plus t squared over 2 plus t plus c. Nice. Uh-oh, we got a number in front. Remember when we took derivatives and we had like the derivative of 3 sine x? We had a constant multiplier. What do we do with constant multipliers? We just keep them, right? That's what we do with antiderivatives. So we want the antiderivative of 3x cubed. So I'm just going to keep this 3 here and multiply by the antiderivative of x cubed. Yes, Ryan? So it'll be 1/4 x to the 4th plus c. And I wouldn't leave it 3 times the 4th. You know, what is 3 times the 4th? So we can just write it as 3/4 x to the 4th plus c. So if you have a number in front, yeah, you add 1 to the exponent. If there's something in front other than a 1, if you have a coefficient other than 1, just take it and divide it by the new exponent. You can do it in one step is what I'm saying. You don't have to, leave it, find the antiderivative. You could just do it all at once. All right, what's going on here? Oh, this is not bad. All right, we got number 7. It's brave enough to get the first term of our antiderivative. Many. 2/3 x cubed. Beautiful. Second term. Riley. Minus 7 over 2 times x squared. Nice. What about the antiderivative? We got the minus 8. Let's take the antiderivative. Minus 8x. And then we need plus c. Okie dokie. Let's try number 8. I'm going to go down here. Yeah. Well, because, okay, the rule it comes from is this one. But, just so you understand it, you're trying to figure out who has a derivative of negative 8. When you get the antiderivative, you're saying the antiderivative of 8 is the function whose derivative is 8. So that would be 8x. Another way, if you want to think about using the power rule, you can think of this as being, when you integrate 8, think of it as being 8x to the 0. Because x to the 0 is 1, right? You can use the power rule, actually. If you add 1 to the exponent, it would be 1. And then divide by the new exponent, you would get 8x to the first. Just one term. Right? So you can think of it as a constant as being a constant x to the 0 and use the power rule. Or you just remember the separate rule from grade constant. Okay, woo! Now remember, you know, when you have fractions in front, after you add 1 to the exponent, like here, we'll add 1, we'll get 6. Either you multiply by a 6 or divide the whole thing in front by 6. It's going to be the same. Ooh. What's that? You want to try this one? Okay, yeah. All right, complain, but it's right, but come on, you got to complain over that. Riley, you complaining? Oh, but aren't you guys confused by that? No? Yeah? Yeah. So if you leave the 3/4 there and you just integrate the x to the 5th, you add 1, that's 6, right? And then you got to put a 1/6. Now, when you multiply this, as he said, it was 3/24, but that reduces to 1/8. All right? All right, Riley, you want to get the second term? What's the next one going to be? Plus 5 over 9x cubed. Because he had the 5/3 there, and then he has to multiply by the 1/3 x cubed. That's why he has 5/9 x cubed. Nice. Now we got the antiderivative minus x over 2. Okay. Looking good. And I can always check it too. You know, if I take the derivative of it, I get minus 2x over 4. That's minus a half x. Beautiful. Oh my gosh, look at that one up there. Doesn't it look so difficult? A pi in there. What is that? Pi's a constant, right? Just like a 3 or a 4 or anything else. Just a constant. All right, so we're integrating a constant times x. Yes, Jen. Yes, I over 2x squared. Right? You add 1 to the exponent, so that's why it's x squared, and then you multiply by a half. That's why it's a half times pi is pi over 2. Nice. Ooh, now we have to integrate the 1 over pi. We're just integrating a number. Think about when you integrate a number, what you do. Who said that? Say it again. 1 over pi times x. Right? Whenever you just like that 8 before, right? When you integrate 8, you get 8x. If you integrate 3, you get 3x. Well, if you integrate 1 over pi, you get 1 over pi x. Let's see. Yes. Yeah. All right. You're sick of exponents that are positive integers? Yeah, I know. You are. You are. All right. So here's the thing. That power rule, it only works when x is in the numerator. You can't use the power rule in the denominator. Yeah, so you move it to the numerator. Big deal, right? So if you want to integrate 1 over x squared, you got to rewrite it as x to the negative 2. Now you could add 1 to the exponent. So the new exponent is negative 1. Remember, guys, when you're adding 1, you move right on the number line 1. And then you got to multiply by the reciprocal. of the new exponent, or divide by the new exponent. What's out here? Negative 1. The reciprocal of negative 1 is negative 1. You divide by negative 1. So it's going to be negative 1 over x plus c. And if you don't believe me, take its derivative. All right, that's a good one to do. All right, well, I'm going to pick I want to pick two more that are like the worst ones to do. Give me one you think looks a little bad. 14 looks good. I like 14. Let's rewrite this. 1 over the square root of x is x to the negative 1/2. Oh, this is nice. They've already left it as x to the 2/3. Okay. So let's integrate the x to negative 1/2. Add 1 to the exponent. That's negative 1/2 plus 1. Negative 1/2 plus 2/2 is, nope, positive 1/2. And then you have a choice. You can either divide by 1/2 or multiply by the reciprocal. You want to have 1 over 1/2 here, or do you just want to take the 1 and multiply by 2? So what goes out front? 2. And if you're not sure, chuck it. Take the derivative. Bam. All right, moving on to the next term. Add 1 to the exponent. 2/3 plus 1. 2/3 plus 3/3. Okay. Now, what goes out front? Either you divide by 5/3 or multiply by 3/5. Personally, I think it's easier to multiply by 3/5. Positive or negative, though? Because it was a negative. Yeah, so minus 3/5 x to the 5/3 plus c. So I have to, you know what? I just got to go right to the little, I hate to say tricks, but I have to say tricks. Well, techniques. Let's call them techniques. How about that? Look at number 16. We're asked to integrate the quantity 2x minus 3 squared. Whenever it comes to integrating sums or differences, easy schmeezy, just integrate everyone separately. The products and quotients, you always have to do the work first. So before you can integrate, guess what you have to do? Boil it out, square it out, right? You're going to have to do the multiplication first. So, do you guys know what you get if you square out 2x minus 3? If you square 2x minus 3, what's the first term? 4x squared. Right, you always get the first term squared. Twice the product to the middle term. And then plus 9. All right, now we can integrate term by term, right? So, let's get the antiderivative. But we had to multiply it out first. What's the antiderivative of 4x squared? Four-thirds x cubed. Nice. What about the minus 12x? Minus, beautiful. Right. Ooh, what about the plus 9? Plus 9x, you're getting better at that one. And then we need a plus c. No problem, right? But we had to multiply it out first. Division's the other guy you got to watch out for. Right? For when you have something like you have a quotient, you can't integrate the top and the bottom separately, just like when you take derivatives, right? But we just don't have a quotient rule for integration. So you actually have to do the division first. You're going to have to break it up. In other words, you're going to take x squared over x to the 4th. That's 3x over x to the 4th. That's 1 over x to the 4th. And not only do you have to break it up, which you know is okay because when you have fractions with the same denominator, you can combine them. So you know you're allowed to break it up. But you still have to simplify these so you can integrate it. How would I write x squared over x to the fourth? That's x to what exponent? Not negative 2. You with the same base, you take the exponent on top and subtract the exponent in the denominator. What about 3x over x to the fourth? How can I rewrite that? To the negative 3. 3x to the negative 3. What about 1 over x to the fourth? How can I write that? So we had to, with this division, break it up, simplify. Now we can go ahead and get the antiderivative. We had to do all that prep work. What's the antiderivative of x to the negative 2? Oh, that was good. It is negative 1 over x. I can't do that to kids. They'll be all confused. Negative x to the negative 1. What is negative 1 over x? What about the next one? Minus 3 halves x to negative 2. Right, because you'd add 1 and then divide by the negative 2. What about the next one? So x to the negative 3. Oh, we can put it over negative 3, or we can put a minus 1/3 in front. Oh, I'm collecting those if you want to give those. I was going to give you this thing. All right, just for the final summary, putting that up there. What you didn't get the answer? Sorry. Homework is 1 to 18 on there. You're very welcome. Yeah, you just continue on the back. Awesome. And your name's on both, right?
Yep.
Yeah, I'm collecting them.
First.
Good. That's fine. You need to make sure I'm getting the work with it. How are you kids doing this? Let me just stop this thing from recording. Okay. Oh, nice. Okay. Oh, that's right. But they going to like a college. Oh, okay. Wonderful. Those girls. Yes. Let me just get this thing to stop recording.